Inside the nanofab, chemicals are used in many of the processes to the extent the chemical safety deserves its own video. This video will cover chemical storage, use, and disposal, as well as what to do if there is a spill or in case of chemical exposure. Every chemical used in the nanofab has a Material Safety Data Sheet, or MSDS. You can find these in the yellow hazardous information box. The MSDS contains data about the chemical, such as toxicity, health hazards, first aid, reactivity, handling and storage, disposal, and chemical properties. Read the MSDS before using any chemical for the first time. An MSDS must be provided for any new chemicals brought into the nanofab. If you need to bring in a specific chemical, material, or gas that is not currently available, then you are required to fill out the chemical request form located under the safety section on our website. We will ask questions about your processes, any potential safety hazards, disposal, and storage. You must attach the corresponding MSDS to the request form and then turn it into one of the lab staff. Wait patiently for approval before bringing any new substances into the fab. Chemicals are stored in separate chemical cabinets depending on the classification of the chemical. Solvents are stored together, acids are stored together, bases, salts, and so on. Violent reactions can occur if acids and solvents or acids and bases are mixed carelessly. You may not store chemicals in dry boxes or on tables and benches. All chemicals must be stored in an authorized containment vessel and clearly labeled. Once a chemical has been opened, do not store it in the chemical cabinets. Open chemical bottles have specific locations under the wet benches and fume hoods. Transporting chemicals from storage must be done only using a chemical cart or a bottle carrier. When working with strong acids, bases, and other dangerous chemicals, you must wear the proper safety protection: a chemical apron over the cleanroom suit, a face shield over your safety glasses, and chemical-resistant rubber gloves. The gloves used in the cleanroom are to control particles. When working with any chemical in the fab, you must additionally wear white chemical gloves. Put them on over your blue gloves and discard them when you are done. Never operate door handles or equipment while wearing chemical gloves. Residual chemicals on the gloves can contaminate surfaces and cause serious injury to others. The front of the chemical apron is labeled "This side out." This label should always face away from you to prevent chemicals that may have been spilled on the apron from being placed next to your body. The face shield helps protect your face from accidental chemical splashes and must be worn at all times when working with strong chemicals. Make sure it fits properly and adjust it if necessary. When using the black rubber chemical gloves, inspect the inside of gloves for moisture. Do not use gloves that are wet inside. To test the gloves for leaks, first open them wide, then fold over the open end so that air is trapped inside. Squeeze the glove, and if you hear or feel air escaping, there is a leak. Do not use gloves that have a leak. When you are finished with the gloves, thoroughly clean them off in the glove wash before removing them. Do not use one glove to grip the inside of the other when taking them off, or this will contaminate the inside of the glove. Instead, take them off by pulling on the fingers. When working with chemicals, do not taste, smell, or touch any of them. Also, eating or drinking in the nanofab can cause you to accidentally ingest dangerous chemicals. No eating or drinking ever in the nanofab. It is important to know what containers are compatible with the chemicals you are working with. Some chemicals, like piranha etch, cannot be used in plastic containers, while others, like hydrofluoric acid, should not be used in glass. A few chemicals used in the nanofab can be especially dangerous. The NFPA diamond or fire diamond allows us to identify with a glance the potential hazards of a chemical on a scale of 1 to 4 in 3 separate categories: health, flammability, instability or reactivity, The white diamond is for special properties to be aware of, such as reacts with water. Hydrofluoric acid. It penetrates tissue more quickly than typical acids, and because it interferes with nerve function, burns are often not initially painful. It dissolves calcium from your bones and can cause cardiac arrest. Buffered oxide etch, a mixture of hydrofluoric acid and ammonium fluoride. Although less reactive than 49% HF, it still presents the same level of toxicity to your body, even though it contains much less HF. Sulfuric acid can cause burns that are potentially more serious than those of comparable strong acids because there is additional tissue damage due to dehydration. Hydrogen peroxide, a strong oxidizer that can cause burns to skin, eyes, and respiratory tract. Potassium hydroxide, a strong base also capable of severe burns and irritation of the respiratory tract. There are also solvents like acetone or methanol, whose fumes can cause dizziness and are extremely flammable. Even chemicals like photoresist, which are not a strong acid or base, can still cause permanent liver, kidney, and nerve damage with long-term exposure to the fumes. Never mix chemicals except as directed by an approved SOP. Careless mixing of chemicals can lead to violent reactions. Also, always add acids or bases to water, never the opposite. When using chemicals, be sure to do so in approved fume hoods or wet benches. Both have special ventilation to pull the fumes that are released up and away from you. Another benefit of using wet benches and fume hoods is spill containment. Using chemicals outside of them can be dangerous. Occasionally, it may be necessary for you to leave a chemical dish or container of chemicals unattended. If this is the case, then make sure to label the container using a label from one of the sheets posted at the wet benches. Include your name, date, a way to contact you, and the name of the chemical in the container. The spill kits located in the lab are for use by the lab staff to contain, neutralize, absorb, and dispose of chemicals cleaned up in a spill. If there is a spill, do not attempt to clean it up yourself. Instead, immediately alert lab staff and evacuate the area. Both acids and bases can be poured down the wet bench drain for disposal, but not at the same time. Always run water before, during, and after pouring them down the drain. To empty out the chemical baths, use the aspirator to suck out the chemicals. Make sure that the chemicals in the baths have cooled to room temperature before using the aspirator. Also, any containers used to hold chemicals must be rinsed with water a minimum of 3 times. Dispose of solvents by pouring them in the designated solvent waste storage container. Be sure to replace the lid after doing so. Photoresist contaminated wipes and pipettes should be disposed of in specific vented trash cans just for photoresist. If dangerous chemicals splash on your clothes or skin, then immediately use the chemical shower. While showering, remove affected clothing and have your buddy summon appropriate medical assistance as soon as possible. Be sure to rinse for at least 15 minutes. For chemicals in your eyes, use the eye wash station. Rinse for at least 15 minutes after opening your eyes. For HF exposure, follow the procedures posted at the wet bench. Flush the affected area with water for 2 to 5 minutes, then apply the calcium gluconate gel. Massage the gel into the affected area and then call for medical assistance immediately. Take the packet from the wet bench with you. If you have any questions or are unclear about any aspect of chemical safety, don't hesitate to ask a staff member for help.